My name is Sandy Winarko. I'm a program manager with Microsoft Information Management team based in Shanghai, China. Today, welcome to a deep dive into SQL Server Integration Services, or SSIS 2017 and beyond. I highlight the word beyond because this is the first time that SSIS actually launched as a cloud-first product. As you know, we have just announced a public preview of SSIS as a PaaS solution, Platform as a Service, within Azure Data Factory v2. Okay? So with this session, I hope you can learn how to use SSIS in general to modernize your ETL workflow, your traditional on-prem ETL workflow, and then you can guide or recommend to your customer to use it, and transform the ETL workflow into a modern hybrid scalable ETR or ELT workflows. Specifically, though, I would like you be able to use SSIS Azure Feature Pack to connect to Azure Data Store and Compute Resources. You can use the new scale-out improvement to execute packages in parallel to reduce your overall execution time. And finally, you'll be able to lift and shift your ETL workloads to the cloud using SSIS PaaS solution in Azure Data Factory. So this session has 3 parts. I will go quickly on introduction. I'll cover Azure Feature Pack new features quickly. And I talk about scale-out feature. And finally, I'll focus more on the PaaS solution within Azure Data Factory v2. Let's start with a quick introduction, just for to get everybody on the same page. As you all know, SSIS is a traditional ETL platform to build enterprise-grade data integration solution. And mostly it comes bundled with a SQL Server on-premises. It's been around for 10 years. It offers user-friendly, code-free authoring tool and management tool in the form of SSDT, SQL Server Data Tools, and SQL Server Management Studio, or SSMS. It also offers a wealth of connectors and transformation to process ETL workflow with various sources and destination. So what is new with the latest SSIS 2017? On the Azure Feature Pack side, we introduced 2 new ADLS, Azure Data Lake Store component, which is the ADLS file system task. I'll show you how to use it. And also, we introduced the for each ADLS file enumerator. On the scale-out solution, it's been released like a year ago, but we have added a new user-friendly scale-out manager UI to manage your worker nodes. We also introduced a high availability support. And finally, we also improved the logging for the workers. And last but not least, SSIS 2017 is the first version that actually runs everywhere. We have SSIS 2017 runs on Linux. We'll reserve that for another day. It supports Ubuntu and Red Hat Enterprise Linux. And also, now SSIS 2017 is a cloud-first product. Essentially, it will become a product that only released in the cloud, and all new feature will always go to the cloud first and backported to the box product. And this has come with Azure Data Factory version 2 as a PaaS solution. Let's start with Azure Feature Pack. There's a lot of materials that I will cover, so I hope you guys bear with me and you reserve the question at the end of the session. So that way I can show you all the demo and all the contents, and then we can take the question later, okay? So in the Azure Feature Pack, I will focus more on essentially on the connectivity components for ADLS, the Azure Data Lake Store. I'll iterate through all the components available, especially the new one, and then I'll show you a demo quickly on those components. A little bit of background on Azure Feature Pack. Like I mentioned before, SSIS is essentially in the past used to do ETL workflow from on-prem to on-prem. But with the recent all migration to the cloud, customer wants to start using cloud data sources, destination, and transformation. So Azure Feature Pack is an extension to SSIS to connect to Azure Data Store and Compute Resources. It provides all this connection for Azure Data Lake Store, SQL Data Warehouse, HD Insight, Azure Blob Storage, etc. And you can see Azure Feature Pack has 4 different groups of components. The first group is essentially the connection managers. There are connection manager for blob, there are connection manager for subscription, and etc. Well, for this session, we'll focus on the connection manager for Azure Data Lake Store, or ADLS. And there are components group that provide control flow, or tasks. There's a Azure Blob upload and download task. There's a Azure HD Insight create, delete, cluster task, etc. But for this session, we'll focus on the ADLS file system tasks. And there's the data flow components. For this session also, we focus on the ADLS source and destination. And then the enumerator group, which we will also introduce for each ADLS file enumerator. Azure Feature Pack support all version of SSIS, all the way to 2012 version. Let's start with the ADLS introduction just quickly before we go into the ADLS connectivity components. ADLS is a hyperscale repository of all kind of data, structured, unstructured, semi-structured. And SSIS ADLS connectivity components will help you build ETL workflow and connect to ADLS to move data from and to ADLS. There are other methods to move data from and to ADLS, but SSIS is one of them. To connect to ADLS, we have to support Azure Active Directory, because ADLS support only AAD authentication. ADLS Connection Manager is the component to connect SSIS to ADLS, and it supports two types of authentication with AAD. The first method is the end-user authentication using AAD user identity. In here, it will allow you to SSIS to connect to ADLS on your behalf. So you actually enter your own credential, username and password, and then through the consent framework of AAD, you provide ADLS access permission for SSIS to connect to it. The second method of authentication is SOS, or service-to-service authentication, using AAD service identity. In here, SSIS will connect to ADLS as a service principal using its own credential. With both authentication, when it's successful, the ADLS will produce OAuth 2.0 token that can be used by SSIS to connect to ADLS using the ADLS API. Let's dig deeper into the end-user authentication. With the end-user authentication, we have done most of the work. We have created a multi-tenant AAD app for you to provide your consent, such that you can delegate ADLS access permission to SSIS. In here, as you can see, when you connect the first time and you do a test connection, it will pop up an AAD consent framework for you to confirm that SSIS can connect to ADLS. In this method, since you don't have to do a lot of work, most of the work are done by us. Although there are some limitations for this, it doesn't support multi-factor authentication, because you can imagine when you do your ETL workflow, you cannot keep asking you to enter your PIN on your mobile or something. And then it also doesn't support Microsoft customer account. Those are accounts that end up with ends with hotmail.com, live.com, or outlook.com. The second method for authentication is the S2S, or service-to-service authentication. For this, you actually have to do a little bit of a setup. You have to actually set up a single-tenant AAD app and assign a role and permission to access your ADLS. But once you do this, you will have three things to enter into the ADLS Connection Manager. You can enter the app or client ID. You can enter the secret key and then tenant name. Once after you do this, then your your SSIS can actually connect to ADLS. Once you have this connection manager set up, then you can use it with all type of connectivity components. For example, the first component that you can use in a data flow is ADLS destination. In here, you can build a data flow to actually write or essentially ingest data, structured data, into ADLS. I mentioned structured data because in this component, you actually have to define the mapping between a source and destination columns, for example. On the editors, you can see that you have you can assign the connection manager that you've just created, or you can create a new one. You can enter the destination file path. You can choose the format. And also in this format, it supports 3 types of format, text, Avro, and ORC. With the ORC, you have to make sure that you have a Java runtime environment running on your machine that have SSIS to do a data serialization. On ADLS source component is similar. This component is used to build a data flow to read a structured data from ADLS, essentially to extract data. On the editor, you can put the same thing. You can put the existing ADLS connection manager that you have created before, or create a new one. You can enter the source file path. You can choose the format. And because it's a structured data, you can define the metadata and data types for in the source column. It only supports text and Afro for this time. And now we talk about the new components that we added for SSIS 2017. This one is the new file system task. It actually helps you to upload and download unstructured data. So essentially, you don't have to define the mappings between source and column, because this will allow you to upload and download a bunch of blobs or files, or basically nested files from ADLS or to ADLS. In the file system task editor, you can name and describe the task, and you can choose the operation. Either you want to copy to ADLS or copy from ADLS. And then you can also define the source directory path, the file name pattern. The file name pattern is supported only for the operation to copy to ADLS. And then you can specify the search method, either recursive or non-recursive, through nested files. Then you can choose the ADLS connection manager if you have one already, or create a new one. And one thing that's really interesting is with the copy to ADLS operation, you can actually set an expiry date for your files. So once you upload your files to ADLS, after a certain date, if you set that parameter, those files will automatically delete it. And next, the final component that we added in SSIS 2017 in Azure Feature Pack is the for each ADLS file enumerator. This provides a programmatic access to enumerate files in your ADLS directory. So in this case, you can actually find all the files in your ADLS directory and then assign those files to a script task, for example, and then you can do further processing to it. And in the for each loop editor, you can, for example, you can select the existing connection manager or create a new one like before. You can enter the path of the ADLS directory where you want to enumerate the files. You can decide on the file name pattern and the search method, either recursive or non-recursive. And finally, the most important part is you can assign those enumerated file path or a collection value to a package variable that you can pass to another task, like a script task, for example. So after going quickly through all these connectivity components, I will show you a demo that actually include like 3 packages. There will be 3 packages that I will show you. The first one will showcase the connectivity component for structured data. It will essentially do a round trip. It will use ADLS destination to upload data, basically structured files, into an ADLS folder, and then use the ADLS source to bring it down back to desktop. So essentially a round trip from desktop to ADLS and back to desktop. Just a single file, a structured table. The second package will actually do the same thing, but this time it's a nested file. So multiple files will be uploaded using copy to ADLS file system task. And then from the ADLS folder, we'll do another operation, which is copy from ADLS to bring down all the whole nested files back to the desktop. And finally, the final package will show you how to enumerate files inside an ADLS directory. We'll store the file path that enumerated from ADLS into a package variable, and then we'll pass it to a script task. Sorry. Let me show you the demo. All right. First, I will show you the Azure Data Lake Store account that I have. Okay. I will launch the Data Explorer. I'll show you like all the staging area where we will use for this demo. If it's connected, give a second. Okay. Okay. So in here, This is where the folder where we do the round trip for the ADLS destination and source. In here, this is a still empty folder right now, but this is where we do the round trip of nested files from desktop to ADLS and back to desktop. Let me get back. And in here, we'll show you like there's a nested files already stored in this directory. We will enumerate it using the third package. Okay, let's do the demo now. Launch SSDT. So this is the first package. The first package is a control flow with two data flow, upload and download. The first one is using the Azure Data Lake Store destination, right? Like I mentioned before. And the download, you will use the ADLS source. Let's run this. So we'll pick up a file from the desktop, put it in ADLS, and back to the desktop. It's done. I'll show you. By the way, I forgot to show you the source. Give me a second. So the source is actually here. This file, a very simple file, number, letter, right? And after that operation, it should actually save that in this folder. It's already run. Let me start again because it's I didn't show it before. Delete. Okay, let's start again. Let's run again. Okay. Now it should be there. You see? All right. So the second one is actually will upload and download this whole nested files in the source and put it in this folder. Okay. Using the second package, you can see the upload and download task using the ADLS file system task. Let's run it. So it's uploading the whole nested files to ADLS now. Take a little bit for the network. It's very small. Like you can see yourself, like it's just only like 2 rows. So it is done now. And we can see now the task is filled, right? So like it's actually already made the round trip. And now I will go back to my ADLS store, and I'll show you the staging store where it's actually stored now. Remember I showed you before the folder are empty. So this is now has the staging, the input from the first package. And this one now has the nested files also. So those two packages works. And now I will run the third package, which is essentially will enumerate the files in, let me show you, in the file enum. In here, the nested file, there's like data 1, data 2, nested data 1, data 2, right? Sorry. So let's run this. And you can see I essentially run the package and pass the enumerated file path to a script task. And the script task is just do a simple thing. It just do a message box and display the path. And you can imagine the script task to actually take that path and open a file and process it further, right? So these are all the files that have been enumerated. I'll show you just quickly the container. As you can see, here we use the same connection manager for all the other package. The file enum is the directory where you have the nested file to be enumerated. And then the variable mapping, this is where you define the package variable to pass the enumerated file path. And then inside the enumerator, we pass that variable to a script task, right? And the script task will have an entry point at the main procedure, and then I'll take the input of the package variable. And I'll show you the script just quickly, what it does. Takes a while. Okay. So the entry point is main. You can see it's the script task. It will just enter the main procedure, and then I'll take the user path and just display it in the message box. So that's it. Let's conclude the demo and the section on Azure Feature Pack. Let's move to the second. This is the second part of the session. We'll be going deep into the scale-out feature for SSIS 2017. This is all the subtopics that we'll cover. Mostly, I'll show you how you install the scale-out solution, going through the master installation, worker installation, and especially I want to show you how hard, a bit complicated or tedious before SSIS 2017 to install this solution, and then how easy it is with SSIS 2017 using the user-friendly scale-out manager to set up this solution. Then later on, I will show you what's the license requirement for this solution, and then I'll do a demo also. Let's go into a bit of a background, how the scale-out feature comes about. We've been seeing from our telemetry and from our survey that the overall execution time across our customer keep increasing. And this increase is essentially driven by three factors. There are more and more packages that you guys want to execute. There are more and more data volume from various sources that you want to process. And the complexity of transformation tasks within your packages just keep on increasing. So a lot of customers are actually requesting a scale-out solution that actually span both on-premises machine and cloud VMs. So for this, and also they mentioned that they want to have a solution that can be easily managed with existing tools like SSDT or SSMS. And some customer who wants to go all out to the cloud, they mentioned that they don't even want to use an on-premise machine at all. They would just want to use a combined scale-up and scale-out solution in the cloud to essentially get rid of all their on-prem infrastructure and reduce their execution time further in the cloud. So to answer their request, we offer a scale-out solution, which is essentially a solution that can be deployed on a mixed cluster of on-prem machine and Azure VM. It's actually, there's a correction there. It's not just Azure VM. It's actually any VM that runs Windows machine. So you can actually have a solution that you can deploy on a cluster that has machine on premises, machine on Amazon, machine on Google Cloud, and machine on Azure. You can combine them all as long as they're all running Windows, right? And this solution offers a parallel execution at the package level. Let me explain what it means. It means when you have multiple packages that you want to execute and you submit them all together, the solution will actually execute them in parallel across many nodes. It will be a first-come, first-served basis based on the worker availability. The solution consists of a single scale-out master machine and multiple scale-out workers. And the way we offer this solution is by extending the catalog, the SSIS catalog or SSIS DB, to support different multiple scale-out workers, and also by adding, basically improving the interface on SSMS and adding a new one, which is a scale-out manager app to manage the cluster. The scale-out master machine will host SSIS DB and a master service, which is a Windows service. Scale-out worker will host the worker service and SSIS engine. The master service essentially manages the whole scale-out operation and distribute packages equally on a first-come, first-served basis to workers. The worker will initiate SSIS engine to execute packages locally in parallel. And finally, these Windows services, worker service and master service, they actually communicate securely over SSL. The setup of this SSL is the one that's actually a bit difficult before SSIS 2017. After SSIS 2017, the setup of the secure communication will be much, much easier. Let's talk about how this solution actually works, the execution flow. So you can see on this diagram, imagine that the user submit an execution request to SSIS DB through the store proc to execute package A. A master service will actually retrieve that request and create a task, execute package A task. And then a lot of worker service, whenever a worker machine, whenever they are available, they will connect to a master service and ask for any task to be executed next. So in this case, execute package A, for example, is the next one to be executed. So the master service will assign it to the worker. When the worker gets this execution task, it will request for the execution context. The context of the execution is essentially the package itself, package A, and then the runtime information. Once the scale-out worker get all this information, it will spin out the SSIS engine to execute the package and start monitoring the execution. And it will keep updating execution status on SSIS DB. And when the execution is completed, it will update the final status on SSIS DB, clean up the environment, and then go back to master service to ask for another task. And that happened with multiple workers. They're all like just independently keep requesting tasks and completing tasks. Okay? That's how it works. The same solution actually will be implemented in the PaaS later on. I'll show you that. So now let's see how you actually install this solution. The way you install it is you install SSIS 2000, basically SQL Server 2017 on multiple machine. On the machine where you want to install the Scale-Out master, you have to install the DB engine and select that machine to be a Scale-Out master. On the feature selection page on the SQL Server installation wizard, you have a choice either selecting it to be dedicated for just master service, a Scale-Out master, or if you want that machine to not only manage the Scale-Out operation but also execute packages, you can do a side-by-side installation so that machine can actually serve as a Scale-Out master and Scale-Out worker at the same time. And then on the server configuration page, you have to select a Windows account that will start the master service and its startup method. By default, a new Windows account will be created, and the startup service will automatically start it. So you don't have to do anything, we just click next. And the important part is next is on the database engine configuration, you have to make sure that you select a mixed mode authentication, which is Windows and SQL. The reason being is a SQL authentication is the one that's used by worker service to write back execution logs in SSIS DB. If you don't do that, then the worker service cannot access SSIS DB, which is hosted in the Scale-Out master machine. Next, on the Scale-Out configuration page, you need to specify the port and the SSL certificate that will be used for master worker communication. By default, the port on the Scale-Out master machine is 8391. And the SSL server certificate, you have two choices. Either select a default self-signed server certificate that will be installed, or select an existing certificate that's already been on the machine. On both cases, when you do this, the corresponding client certificate, SSL client certificates, actually have to be taken and installed on each of the worker machine. That is the part that's actually a bit tedious later on. Now you have the Scale-Out master installed. Let's see how you install the Scale-Out worker. On the Scale-Out worker machine, on multiple machine, you also need to install SQL Server 2017. But in this case, you don't have to install the database engine. You just install the SSIS, and you select Scale-Out worker. And here, similar to the Scale-Out master installation, you have to select a Windows account to start up the worker service. By default, it will be a new account. And by default, it will be automatically started. Now, you have to open using the Windows Firewall app. On the Scale-Out master machine, you have to open two ports. The 8391 is to ensure that the worker service and master service can communicate to each other. And then 1433 is to open up access to SSIS DB so worker service can write execution logs. On the worker machine, the Scale-Out worker machine, you actually have to open a port 445. Or just select a predefined inbound traffic rules, which is a remote service management rule. By doing this, this actually will enable Scale-Out master to write or to check the certificate stores in the Scale-Out workers. So when you do this, then you're essentially ready to install the certificate for the machines. And this one is just, you just need to check using the Windows Services app. You need to make sure that like a worker service and master service are running in each of their own machine. Because when in the installation, we choose as an automatic startup method. So in this case, master service will automatically start it in the Scale-Out master, and the worker service will automatically start it in a worker machine. And when you do that, the worker service will actually register to Scale-Out master, and Scale-Out worker essentially will get a unique worker agent's ID stored in SSIS DB. This worker agent ID stored in SSIS DB will be used to enable the Scale-Out worker. Now, this is the part that actually I mentioned before. Before SSIS 2017, there's a tedious kind of like not complicated, but like a bit of a work to secure the master worker communication. In this case, like I mentioned before, you actually have to exchange the SSL client certificate. You have to move the SSL client certificate of the master and install it to the worker such that the worker can authenticate the scale-out, worker service can authenticate scale-out master machine. And vice versa, you have to install the SSL client certificate from the worker machine to the master machine such that master machine can authenticate the scale-out worker. So there's a lot of work you need to do manually or use some Microsoft Management Console, but the best way to do it is using Scale-Out Manager that introduced in SSIS 2017. And then also another step that's like a bit tedious is before 2017 is when you want to enable the scale-out worker, you actually have to execute a store proc in SSIS DB, which is an enable worker agent. And you have to use the worker agent's ID for each worker on SSMS that's connected to the scale-out master to do that. So it's a bit complicated. So let's see how do we improve it with the scale-out master manager. Sorry, the scale-out manager. So the way you do it, you connect SSMS to the master. You launch it as an administrator. And then when you click, right-click on the SSIS DB, you launch the menu Manage Scale-Out, and it will launch an app, which is the Scale-Out Manager. When this app launches, you can see if a Scale-Out master is already enabled or not. So this is automatic. And you can, on the dashboard, you can see the Scale-Out master status. And on the worker manager dashboard, you can see all the workers that connected. Are they enabled or not, etc. And if you want to add workers, very simple. You just go to the bottom of the app. You have a plus and minus signs. When you click plus, you essentially requested to add more workers to the cluster. Or if you want to delete the workers, you can just click on the minus, and then you go through the process. Let's see how we add new workers to the cluster. So when you click plus, there will be the dialog open, and you enter the machine name for the worker. And then you click validate. When you do validate, essentially the scale-out manager on the master machine will try to connect to the scale-out worker and try to access the certificate stores of the worker machine and try to actually update the config file so you can actually put the scale-out master connection endpoint in the scale-out worker and also put the master certificate thumbprint in the scale-out worker. If it's all successful, it will show you that these are the steps that will. So all these steps in the yellow, it's probably too small for you to see. But those steps before SSIS 2017, you have to do it actually manually. Now you can actually do it automatically here. It shows that the Scale-Out Manager will install the Scale-Out Master client certificate to the worker and install the Scale-Out Worker client certificate, SSL client certificate on the master. Will update the master connection endpoint. It will update the certificate thumbprint and then restart all the Scale-Out Worker service. So all this stuff will be done automatically. All you need to do is like check on the confirm that all action will be done. And if there's anything fail or if there's an issue, it will offer you a way to do it manually. For example, if you cannot access, if a scale-out manager cannot access the scale-out worker config file, it will show you how to do it to pick up a thumbprint and put it there, or you can put the scale-out certificate file and you do the same thing. And when it's successful, we'll just give you a check mark on all the action that's been completed. And then you can see now, I have added a scale-out worker. By default, the scale-out worker, additional scale-out worker will be added disabled. And all you need to do is just enable it. And when you enable it, now you have two workers. For example, in this example, I have two workers connected to my master, and I can start executing packages in parallel. Executing packages in parallel is very simple. With the SSMS on the master machine, you can just select the menu, right-click, select the menu, execute in scale-out, and open up a dialog window and show you all the packages that have been deployed to the scale-out master machine on the SSIS DB, and you can pick which packages you want to execute in parallel. And next, you can select which worker machine that you want to participate in this parallel execution. By default, all machines will participate in this parallel execution. And that's it. And finally, I will just give you a highlight about the high availability support. Before 2017, we don't have HA support, but now we actually have support on both sides, the worker side and the master side. The worker side has been there already because we have a multiple scale-out workers. When one fails, the other one will pick up the work, right? But the master side high availability is now can be supported through a Windows failover cluster. So this is a cluster of Windows machine running multiple scale-out masters, and also SSIS DB always on. So when you set up the Windows failover cluster and always on for SSIS DB, whenever the master, the primary node are down, the backup service for master service or the replica for SSIS DB will pick up the slack, and any secondary node will pick up the slack and continue to serve and work with the existing worker. So this solution, the detail of the setup is actually in the deck. When you can download it, you can click on it, and there's all the information how to set up a HA support. And finally, the license requirement for this solution. For the master, it requires an enterprise license, and it also requires a SQL Server to be installed on the master machine to host SSIS DB. On the worker, you can choose either standard or enterprise license. You do need to install an enterprise license in case your packages that you want to execute in parallel have features that only supported by enterprise license. For example, the Oracle or Teradata connector, or the CDC change data capture. Okay. But on the worker, you don't. It's not required to install a SQL Server. Just the SSIS engine need to be installed. Let's do a demo. So in this demo, I've installed SSIS 2017 and the Scale-Out feature on 3 VMs, all in the cloud, 1 master and 2 workers, and I actually have 2 packages. This package do a simple thing. The first package will just move content from one table in Azure SQL 1 to another table in Azure SQL 2. The second package do the same thing, but it will be executed by the second worker, and it will just also move another table from one Azure SQL DB to another Azure SQL DB. Let's see the demo. Okay. All right. So I have a SSMS already connected to my master machine, and you can see the master machine hosts SSIS DB and already deployed packages that I want to showcase. These 2 packages, the SQL DB table 1 to SQL DB 2 table 1, SQL DB table 2 to SQL DB 2 table 2, those are the 2 packages that I want to execute in parallel. I will show you what our table 1 and table 2 look like. The source in the SQL DB 1 is essentially a basic, like all my demo. This is like a table 1 in a SQL DB 1. This is table 2 on SQL DB 1. And I want to move it in parallel to a SQL DB 2. Right now, table 1 in SQL DB 2 is still empty. And table 2 in SQL DB 2 is also still empty, right? Okay, let's run this. Oh, by the way, I'll show you how to, let me see. This is the managed scale-out before, so you can see that the application, the scale-out manager, where you can see I have a master enabled and have 2 workers already enabled, right? So this is very user-friendly management for a scale-out cluster. Okay, and if I want to execute those packages in parallel, I just select execute in scale-out. And you can see all the packages that's already been deployed to the SSIS DB, and I'll just choose those the 2 packages. And next, it's running. And I'll show you, so this is 14 and 15. One is running, the other one is pending execution. It's running all in parallel. Now both are running. And you can see it's automatically distributed to both of my machines. So one is done in the worker 1, the other one is being done on the worker 2. All in parallel. Let's see. That's it. So both packages have been executed. They're both completed, and let's see the result. And this is the SQL DB2. The table 1 should have the same content like a table 2. Table 1 should be the same content like in SQL DB1. Yep, it works. There you go. So that's a demo of a parallel execution using Scale-Out. Okay. So now we are going to the cherry on top of this session, which is the PaaS solution. So we have announced it in public preview in this in Ignite, SSIS as a PaaS solution within Azure Data Factory version 2. In this part of the session, I will cover what is the background, in how the solution come about, what is the customer request. I will show you how it fits SSIS into the ADF basic concept and introduce a new concept which is called integration runtime. And then I will go through the end-to-end user journey to provision the SSIS PaaS within ADF v2, how to deploy packages, how to execute them, how to monitor the integration runtime or the compute resource, how to monitor package execution, how to schedule them, and finally I'll show you the pricing, and I'll run a demo also. So let's go. First, the background, right? As I mentioned before, SSIS is a traditional ETL tool, usually used for on-prem to on-prem movement, but a lot of customers are actually start wanting to lift and shift their workloads to the cloud. They don't want to run their workloads on-premise anymore, but in the past, they don't have a solution like that can be managed for them, so they actually have to manage everything by themselves. So they run SSIS on IaaS, just like I mentioned in Scale-Out solution, but managing VMs could be challenging, right? And we have also data integration tool, which is Azure Data Factory, which is a modern ELT tool. And this tool will move and copies data and dispatch transformation for big data analytics. But a lot of ADF customers right now that are actually familiar with SSIS, they see some gaps in their ELT workflow. They want to actually able to use built-in tasks or a code-free transformation authoring using SSIS. So they've been doing it themselves, combining SSIS and ADF using, again, IaaS or Azure VM. And essentially managing those machines is challenging. So essentially the evolution is like almost a natural evolution that's happening with SSIS from on-premises to IaaS, Azure VM, and finally to PaaS, to a full managed solution. The stage is essentially set for a PaaS solution. And the way we do it is like we are building this solution phase by phase to offer a unified platform for Microsoft ETL and ELT services in the cloud. We start with the two tools separated, ADF in the cloud and SSIS on premises. In the phase 1, we actually use ADF version 2 to provision SSIS PaaS. The way we do it is like when you essentially have to create a Azure Data Factory first, and then use the Azure Data Factory app or SDK or API or PowerShell to provision a compute resource that can execute SSIS packages. This compute resource is called Azure SSIS Integration Runtime, or for short, Azure SSIS IR. Once you do this, you can still use the existing familiar tool like SSDT and SSMS. You can still use SSDT to design packages and deploy packages to the IR. You can still use SSMS to execute and manage packages in IR. So the IR can be treated almost like a SSIS on premises. This is really targeting SSIS customer who wants to purely lift and shift their packages with minimal or no change to the cloud. And also, we open an interface for independent software vendors to build extension to SSIS in ADF, and also to create, for example, a software as a service based on SSIS PaaS. Introducing the Azure SSIS IR, it is essentially a managed cluster of Azure VM or nodes. This cluster of Azure VM is dedicated to run only your SSIS packages and no other activities. It's what we call managed dedicated solution. When you specify it, when you provision it, you can scale it out, scale it up or scale it out. You can specify the node size of, for each node, and then you can specify the number of nodes in your cluster. For SSIS DB, you can bring your own Azure SQL database or managed instance, which is a new variant of Azure SQL database that provides almost close to 100% backward compatibility with Azure SQL Server, with SQL Server on premises. So you can choose these two solutions to host SSIS DB. And you can decide if you want to join your integration runtime into a VNet in case you have a requirement for on-prem data access. So if you have the data sources or destination in your package that actually are on-prem, then you need to join your integration runtime inside the VNet. And finally, once you provision all this, all you need to do is just enter your Azure SQL DB server endpoint or managed instance server endpoint on SSDT and SSMS, just like the way you do before. And then suddenly you connect SSMS to your SSIS PaaS, and you can simply deploy packages, configure, execute them, just like SSIS on premises. There's no new skill set that you need to learn. Once you provision, you can do everything with familiar tools. So the target for phase one is essentially there are two types of customer that we are thinking that will actually use this solution. The first cohort of customer is what we call SQL migrators. These are the type of customer who actually wants to retire the whole SQL Server on premises. They want to move the whole app and data to Azure. And the best solution for them to do this is Azure SQL Managed Instance, because like I said before, it provides almost close to 100% backward compatibility, right? For this, a lot of Azure SQL Managed Instance will most likely offered inside the VNet. So we'll do support this solution where SSIS DB will be hosted by Managed Instance inside the VNet. The second type of customer is what I call ETL cost cutter. These are customers who are not necessarily want to retire their SQL Server on premises. In fact, they might still have data on premises on SQL Server, but what they want is to actually not running SSIS on premises anymore. They just want to lift and shift the workload to the cloud. For this customer, we can offer SSIS DB hosted by Azure SQL DB, and that can be done in public network. In fact, just for this for Ignite, there's an announcement for Azure SQL DB offering, I think it's called VNet Service Endpoint. We have not tested that solution with SSIS, but with SSIS, with the integration runtime injected inside the VNet, we will make sure that with that will be also can support the new VNet solution on Azure SQL DB. Okay. So now, what are we offering for public preview? So live now in public preview, we support only 2 regions right now, East US and North Europe. But more and more regions are being added after this week. We will go like, depending on the customer feedback, we'll keep adding more regions. We offer 6 node sizes. I will go through what are the sizes right now, the Azure VM sizes. And also, depending on the customer feedback, we'll keep adding in more and more sizes after public preview. For now, we only support a standard license, but in the future, we also add the enterprise license, and we fully support Azure SQL Managed Instance. For the VNet support, right now, we only support Classic, but in the future, we also support Azure Resource Manager or ARM VNet support, and we already support 24/7 lifecycle support. There's one more important point. For now, all the nodes for the PaaS solution, we will only install Microsoft components. So we install, for example, the Azure Feature Pack, Access Driver, or Microsoft Office extension. Custom or third-party component installation will be supported later on. We are working on the interface for you to actually customize your SSIS PaaS. So in this case, you can actually decide if you want to install like a component from a third party, like Kingsway Soft or Pragmatic Works or CozyRock later on, and we'll provide an interface to do that. But for now, only Microsoft in-house components. So once we finish with phase 1, we are now actually hard work in phase 2. In phase 2 is actually we're opening the second door on ADF v2 to actually trigger or schedule, execute packages that's already been deployed to SSIS PaaS. In the first phase, we actually opening the first door only for provisioning. The second phase is actually triggering or scheduling SS packages using ADF v2. Once you are able to do this on ADF v2, we should be able to allow a customer to actually start chaining and grouping SSIS execution with other activities like Azure HD Insight or machine learning, etc. And this is actually aiming for SSIS, both SSIS or ADF customer who want to combine ELT and ETL workflow on a single platform. Like I mentioned before, there are two types of customer. From the SSIS side, they want to modernize their ETL workflow. So they want to start using ADF and using ADF activity combined with SSIS package execution, for example. From the ADF side, like I mentioned before, there are ADF customer who wants to start using SSIS built-in tasks in their ELT workflow. So they actually want to combine SSIS package execution, with ADF activity. So this type of customer, we are targeting for phase 2, and ETA for this is probably late this year or early next year. And then finally, in a phase 3, we don't have a ETA for this yet, but essentially this is our North Star, with the vision actually turning ADF into a single pane of glass to do everything in data integration. So you not only provision, trigger, or schedule, but you can also author rich hyperscale transformation on ADF. This is more targeting non-SSIS, non-SQL, or non-SSIS customer. And essentially, this transformation does not necessarily need to run on the SSIS runtime. It can actually run in a hyperscale runtime in the future, like a Spark cluster with hundreds of nodes, for example. So let's see how this solution fit. How does the SSIS fit in the ADF world? You probably know already the ADF basic concepts, right? ADF allows you to build data pipelines to trigger and schedule their runs. Data pipeline is a chain of group of activities to perform on your data, like transformation or movement. Activities take data sets. Some activities target data store or compute resources external to ADF. So you need link service to represent those resources so ADF can orchestrate them. The new concept is actually the integration runtime. The integration runtime is an ADF native compute resource that can perform data movement and transformation. That includes the SSIS package execution, right? And the type of integration runtime that execute SSIS packages are called Azure SSIS IR. So one takeaway from this is, like, as you can see in the picture, right, you have a pipeline on the green rectangle there. You have activity chains around one after the other. Some activity will be powered by external resources, and some activity will be powered by internal resources or integration runtime of ADF. Those activities are data movement, SSIS, or for example, data wrangling that will produce complex information. From the billing point of view, as I mentioned before, because SSIS will run on Azure SSIS IR, which is native to ADF, so, while SSIS DB is hosted by your own Azure SQL database or managed instance, the billing for Azure SSIS IR, the compute hours will be billed under your ADF subscription, while your SSIS DB will be billed under your SQL DB or managed instance subscription. And that's about it, about the concept and the introduction of the product. Now we'll go to the end-to-end user journey, how to provision, deploy, execute, monitor, and schedule. Provisioning. As I mentioned before, you can actually start provisioning Azure SSIS IR with ADF v2. But the UI for this, ADF v2 app, is still a work in progress. But I will show you what the screenshot look like, because it's easier to see what type of provisioning values that you need to enter with the UI. But what's live now, you can actually provision Azure SSIS IR using PowerShell. I'll show you also the script in the PowerShell. So using the ADF v2 app, you first create an ADF v2. If you have not done so already, you open the ADF v2, and there's a link in the ADF v2 page that you can actually launch the app. This link is not visible for you guys yet, because this is not ready, but I'll just show you anyway what this looks like. So when you click on this link, it opens the ADF v2 app. And in this app, you need to click on the connection, making a new connection. So integration runtime is considered as a connection to connect between sources and destination. And when you click on integration runtimes, and you can click a new one to create a new one, you have two types of cloud integration runtime. The first one is the Azure integration runtime, or Azure IR. This is to perform data movement or dispatch transformation to external compute. This is what normally used in ADF v1. And the second IR is essentially the Azure SSIS IR to lift and shift your packages to Azure. When you click that, you see the blades to set up the compute properties. In the compute properties, you can name and describe your IR. The important part is then you can select the region where you want to host your IR. For now, only East US and North Europe is supported, but in the future, we'll add more regions. One thing that is important to understand is like the region or the location for SSIS IR does not need to be in the same region with your ADF. So your ADF can be in East US too, while your IR can be in North Europe. That's okay. But the important thing is like the region has to be in the same region with your Azure SQL database or managed instance where you host the SSIS DB. The reason being is because you want to have your integration runtime cluster to communicate with the SSIS DB inside the Azure SQL DB, and you want to make sure that those traffic is maintained within the same location or region. Otherwise, you're going to have a cross location and incur egress costs, right? So next, you can select on the node size for the cluster. We have like 6 Azure VM node size that's offered right now, and we will keep adding more and more node size. We offer A4 and A8 and D1, D2, D3, D4 for now. You can select a large node size if you have like a compute or memory intensive packages to run, for example. Next, you select on the size of your cluster. We have a range between 1 to 10 for now, so you can create just one node, just like your on-premises solution, or you can have 10 nodes in the cloud, right? And you usually want to have a scale-out many node solution when you want to run multiple packages in parallel. And similar, because this is essentially a managed cluster of Azure VM, just like Azure VM, you can manage the cost of running it by stopping and starting the cluster. When you stop it, we essentially release the node and stop billing. When you start it, we essentially reallocate the node and start billing. And finally, the SKU or the license will be by default is standard for now. In the future, we'll support enterprise. Once you define all the compute properties, next is you need to define the SQL properties. In here, like I mentioned before, you bring your own Azure SQL database or managed instance to host the SSIS DB. And a selection of database server or managed instance server in the same region with IR will be provided. If you don't have one, you can create a new one to make sure that it's in the same location with your IR. One thing that's important to remember, if you select managed instance and a managed instance inside the VNet, later on in the next blade, you have to make sure that your IR will be injected into the same VNet, so it has a line of sight to access SSIS DB hosted by managed instance. And finally, the endpoint of that SQL database and managed instance server will become the input that you can, connection info that you can enter on SSDT and SSMS. And you have, I guess like you have to put also the admin server username and admin server password to make sure that we are able to prepare and manage SSDB on your behalf. The next two value, the parameters, is only apply for Azure SQL DB. In this case, you need to select the service tier for SSIS DB. You have a choice between like a basic, S1, S2, S3, etc. And you want to select a large tier if you have like more packages to store and you want to have a high database performance in terms of like querying the SSIS DB. And you also have to allow Azure services to access your Azure SQL DB so we can prepare and manage your SSIS DB for you. These two parameters does not apply with the SQL managed instance. So when you select SQL managed instance server, those two input will not be shown. Now, you have specified the compute properties. You have specified SQL or SSIS DB properties. The final blade is essentially setting up advanced settings. In here, you can actually customize the node such that you can actually set the concurrency level inside the node. For example, we have a range of 1 to 8. In this case, you can set a low concurrency level, like 1. In case you have a really big package that you want to dedicate the whole core inside the node and the whole memory to that one package, for example. But if you have a lightweight package that you want to run in parallel inside the node, you can actually have several packages running in the single core. Then you select a high concurrency level for that. And this next step is essentially optional. You can see that. This is where you actually need a VNet. You need a VNet when you have a managed instant hosting SSIS DB inside the VNet. So you also have to inject your integration runtime inside the same VNet. Or if you have on-prem data sources and destination in your packages. So the way for us to enable on-prem data access is to inject the integration runtime into a VNet connected to your on-prem network. And then by default, you also need to allow us to manage the VNet permission and settings so we can actually inject the IR inside that VNet. And if it fails, we actually have a FAQ, online documentation for you to resolve it manually later on. And that's where you enter your VNet resource ID and subnet name. We only support classic VNet for now, but in the future we'll support ARM VNet. And ideally, when you have a solution where you have your IR, Azure SQL Managed Instance, and a VNet connected to your on-prem network, ideally all these three components is in the same location, so you don't have to do anything. But in case they are not in the same location, then you will, it's better for you to provision your IR in the same location with your Azure SQL DB or Managed Instance, and then create a new VNet in that location, and then do a VNet to VNet connection with the VNet that's connected to your on-prem network. Hopefully, not a lot of setup that actually require this type of topology. Okay, and once you enter everything, you are ready to provision. You click on Finish button. What happens is now our backend is start allocating the nodes. It will take about 10 to 20 minutes to allocate all the nodes for the cluster. Essentially, what it does is allocate the nodes, prepare the machine, install SSIS engine, install all these Microsoft components all the drivers, Azure Feature Pack, etc. Right? And then once it's started, and we start building the cluster. When it's ready, the status will be started. When it's started, essentially it's ready for you to deploy packages to it and execute packages on it. And if you want to, if you finish with running your packages and you want to stop it, then you can just click on the stop button whenever you want. And when you stop the button, we will warn you that any packages that are still running will be automatically canceled. And then restarting it will take another 10 or 20 minutes. I think that's still old. In the beginning, it does take 20 to 30 minutes, but now we improve it to 10, 20 minutes, and even we are targeting about 5 minutes for us to spin out the nodes. And then when you stop it, it'll take about 1 to 2 minutes to stop your cluster, and we'll stop billing. Once it's stopped, essentially it's ready for you to edit. You can configure your cluster, adding more nodes, or increasing or increase the size, or even injecting into a different VNet, for example. And if you select to edit your IR, then you will see all the values that you entered before at the provisioning time. You will be allowed to change only the editable ones. Once you edit your value, then you can just restart it. That's it. So once you see that visually, essentially the script that actually live now for you to provision IR is essentially doing the same thing. This is the script actually already all live in the online document. And there's a part of the script that you actually define the variables, the provisioning variables, like I mentioned before, the location, node size, node number, etc. You define the Azure SQL DB or Managed Instance Server endpoint, password, etc. There's a script that actually needed to validate your server endpoint to make sure that it's actually running and ready for us to access, to prepare and manage SSIS DB. This part is very important. In the UI, remember that you have to allow us to essentially to configure the VNet permission and setting for us to join your IR into the VNet. In the PowerShell, you actually have to use the script that we provide you, so that way you don't have to write your own, and you don't have to manually configure VNet permission. You just cut and paste it or run this script, and it will automatically configure the VNet for you. And then finally, this is the bulk of the operation to create. The first one is like to set a data factory, to create a new data factory. Second one is to set up the metadata of all the values that you provided at provisioning. And the start integration runtime is the command that actually will take about 10 to 20 minutes to allocate the nodes and prepare them ready for you to deploy packages. Once your IR is provisioned, you can monitor it using the get commandlet, get the integration runtime. And then later on, if you want to configure it, you have to do you have to stop, set, and start. So you have to stop it first to make sure that all the nodes are released and billing are stopped, and then you can change the configuration of the cluster, and then restart it, essentially. So that's it. Now you have your IR is provisioned. How do you deploy packages to it? The SSIS PaaS in ADF V2 support a project deployment model that's already been supported since SSIS 2012. And here, if you have any packages that you need to change, you actually have to deploy the whole project again. In the future, though, we'll support an incremental package deployment feature that will be coming later on, maybe late this year or early next year. If you have a project that built using SSIS 2008 or earlier version, you can use the IS project conversion wizard to convert it to the latest version. If you have packages built in the earlier version, you can use a package upgrade wizard to convert it. And essentially, the projects will be deployed to SSIS DB, hosted by Azure SQL DB. But the package itself will be run on the integration runtime. So SSIS DB will be the storage or the catalog where you store the packages. The package will be executed on the IR, and the execution log will be written back to SSIS DB. There are 4 methods to deploy it. The easiest one to deploy packages are using SSDT and SSMS. That will also launch IS deployment wizard. We are actually considering a method using command line interface, depending on the customer feedback, if essentially running the IS deployment wizard executable. This is normally used for when you want to automate a batch deployment. And then the next 2 methods is using PowerShell. You can actually deploy packages using PowerShell or custom code with the existing SSIS API, managed object model. And you can also deploy project using a T-SQL script. So this last 2 methods is actually existing with SSIS on-premises already. I'll show you how to do it with SSMS to deploy packages for project. There's a subtle difference between deploying packages, deploying projects or packages using SSMS for a PaaS and for on-premises SSIS. With the PaaS solution, you connect your SSMS to your SQL DB server endpoint. And you enter the endpoint there and a password. But you also need to set the database target for connection. In this case, you have to make sure that the SSIS DB is the target connection. So that means you have to enter your endpoint, and you target SSIS DB is the target database. Once you do that, then you are connected to your IR. You're connected to your Azure SQL database in the cloud, and then you can deploy project just the same way like you do on premises. It will launch the same IS deployment wizard. And that's it. Once you deploy the project in SSIS DB, then you can execute it. The execution is also have same 4 different methods. You can use SSMS to execute methods. To execute packages on an ad hoc whenever you want. We're also considering to offer the command line interface in case there's a lot of customer requests for that, which actually just run dtexec.exe in the command prompt. And the last 2 methods is also using the custom code with the SSIS MOM API and a T-SQL scripts. I'll just show you quickly on the using SSMS. So you can configure. Once you are connected, you have a packages deployed already. You can configure the packages just like on SSIS on premises, right? You can execute it. Everything is the same, so no new skill set to learn. Once you have the integration runtime provision, you execute packages, you want to monitor your integration runtime and the package execution, right? To monitor integration runtime, you can use either the app. The app is still work in progress, so it'll come soon. But you can right now, using PowerShell, you can monitoring it using the get commandlet that I showed you before. For the package execution, you can also use the ADF v2 app later on. That's still coming in the future. But for now, you can just use SSMS to do it, just like on premises. And here is what live right now to monitor your IR. You do the get commandlet. You provide the data factory name, the name of your IR, and the resource group. You can see all the input there, how many nodes being allocated, what's the status, if there's any error, actionable error, etc. In this example, for example, I inject the IR into a VNet. You can see the VNet resource ID and the subnet name, which is default, etc. And on SSMS, you can monitor the package execution using the same the standard report for all execution. When you click on it, you can see all the messages and error messages if you need to debug. And that's it. And finally, you have provisioned the SSIS PaaS. You have deployed packages to it. You have to execute it. You have to monitor it. How do you schedule package execution in SSIS in ADF? There are 4 methods. The ideal method to schedule or trigger execution is to directly explicitly scheduling using ADF v2 app, which is also still in work in progress. But for now, though, you can actually use ADF v1 on the portal to actually indirectly or implicitly schedule SSIS package execution in SSIS PaaS using ADF v1 Sprock activity or using ADF v2 Sprock activity through PowerShell, for example. If you use Azure SQL Managed Instance to host SSIS DB, you can use Azure SQL Managed Instance agent that comes with a Managed Instance server, which is similar to SQL Server agent. If you use Azure SQL DB Server, they have this native scheduler, which is called Elastic Jobs. That's also in private preview. You can use that. I'll show you all the script how to do that. And finally, if you still maintain a SQL Server on premises, you can use on-prem SQL Server agents to schedule T-SQL jobs that execute SSIS packages in the PaaS solution in your integration runtime. Let's see quickly the script to set up an ADF v1 Sprock activity. Essentially, you need to create a link service that's connected to your Azure SQL DB or MI Managed Instance hosting SSIS DB. You create the output data set to drive scheduling, and you create a pipeline with a SQL Server store proc activity. That's a script, the JSON script to create a link service. You can see there the source for this link service will be your SQL DB server name, .database.windows.net, or your Managed Instance Server endpoint. That's the script to set up a data set that drives the scheduling of your package execution. And that is the script to set up a pipeline with a SQL Server stored proc activity. One thing, though, you don't have to create a stored proc activity from scratch. You can actually use the system stored proc in Azure SQL DB, which is the sp_execute SQL. So that way you can just cut and paste a T-SQL script that will actually create and start execution in SSIS packages. The script that you can just cut and paste in the statement properties there is this one. In here, you can see the T-SQL script that can be inputted into the ADF v1 Sprock activity. There's execute a store proc to create the execution object. There's a store proc to set execution parameter. You make sure that you set a synchronized execution parameter such that your store proc activity will exit only when the packet execution exits. So once they exit together, then you can actually use the store proc activity to basically to monitor the execution status. So in here you can see, you can look at the catalog.execution view. If there's a failed execution, you can just pop up the execution ID on ADF, and you can take the execution ID to see what's the problem on SSMS. Simple. Here, I will not go into detail. This is essentially all the script to schedule the SSIS and ADF v2 using Elastic Jobs. Essentially, it's T-SQL jobs using all these scripts. You can use it. You can try it yourself. And here is like how to schedule using a SQL Server agent. The trick is like basically you see it's scheduling the same type of T-SQL script, but you have to set up your Azure SQL DB or managed instance as a link server to your SQL Server on premises. Once you set up this linked server, then you can essentially execute the same script there. Next is essentially the pricing. These are the prices per hour for Azure SSIS Compute. As tradition on a public preview, we have a 50% discount there. And now time for demo. I'll show you a quick demo here. The demo is really interesting because like what I'm doing right now is actually not exactly lift and shift, but it's actually a shift of the package that I showed you before running on the IS, on the scale-out topology. I'll use the same package and deploy it to the PaaS solution and run it without changing anything. And it should be running exactly the same. Okay, let me just set up. A second. And switch. You can see before in the demo that I have before, right? Actually, before that, I want to show you how the provisioning script. Let me just show you how to do it. Remember the script that I showed you before? Those are all the script. This script can actually be cut and pasted from the online document that's live right now. In here, for example, you can enter all the value for the provisioning. Right, what I mentioned before, like the Azure SSIS name, node size, node number. So I already put all the value in there. All you need to do is just like entering all the value all the way up to here. Sorry, that's it. Once you enter all the value, all the script that I mentioned before will automatically execute it, and will provision IR for you. So you just hit run. Oh, sorry, I have to enter. Oh, actually, no. I'm already logged in, so I can just skip that. Yep, I already have a resource group. I already have an ADF. And that's it. So you can see, you just like hit run on that script that we provide online, and you're essentially provisioning an IR there. I'm going to quickly show you what's the current work in progress of our, how to provision using the UI. It's very interesting also. Let's see. You can see here, I have, for example, my ADF v2, right? Provision already. And when you click on this link will not be visible for you because it's not ready yet. But like for our team, you can see, you can provision it here. And then you can see that on the connection and integration runtime, I already have one integration runtime provision. And you can click new. You can select which IR that you want to do. This is the IR to lift and shift. You can click next. You can enter all the stuff that I mentioned before. So let's say it's called demo Azure SSIS 3 and demo. And you can see here, I can just select like 2 nodes, next. And it'll show you all the Azure SQL DB server in the same region. Let me just see. For example, oops, sorry, not this one. This one. For that one is this. Oh, sorry. And here, if you can decide if you want to inject it into VNet or not, I won't do that. I just select a concurrency level, maybe let's say 4. And you just click finish, and it's provisioning right now. So you can see I'm actually provisioning to IR, and you can see it appear now, the demo Azure SSIS 3. It's actually provisioning through the UI and also through the PowerShell. Now let's go back to the execution one. So what you can see here, I already provisioned a PaaS solution. I'll now connect to that PaaS solution, which is called DIS in Azure, right? And remember, you have to use SSIS DB as a target database for connection. Connecting. Now I'm connected as SMS to my PaaS solution. Give me a second. And you can see I have already SSIS there. It doesn't have any packages yet. It's still empty, right? Now what I'm going to do is like essentially shifting or moving the package that I had before in the scale-out solution and basically deploying it in the PaaS solution. Sorry, where is that? Where do you usually? Oops, sorry. Deploy project. Next. I'm going to use integration service catalog. I'm going to use the scale-out master from the previous demo. And that is the project I wanted to deploy. Right. And now, for the destination, I will actually use my PaaS. Okay, I'm using SQL auth, my password. Okay, let's say connect. Yep, it's connected now. I'm going to deploy it into this folder. And that's it. So I'm deploying the same packages I run in the scale-out solution before to the PaaS solution now. So no change in the packages, same packages. It's been deployed. Okay, sorry. Now you can see, let's see, refresh. You see, now I have a same project that I ran before in the scale-out. Now it's actually in the PaaS solution, and I'm going to execute them. The same project, the same package that actually moved a table from SQL DB1 to SQL DB2. Use that one. OK. It's running now on the integration runtime. And you can see it's one of them is a pending execution, the other one is running. You won't see the name of the node here because essentially you don't need to know because it's all managed for you. Refresh. Yes, those the package are both executed, and we can see the result. There you go. So exact same package. Now it's running on the IR, into the integration runtime, and it does the same thing. That's it. Let's see. It's still starting. And I'll show you the monitoring to see like how many IR is actually being provisioned right now. Oh, let me show you in a different part. Sorry, a bit running late here. Let me just, this is the monitoring command. So for the ADF for my Azure Data Factory, you can see that I have 3 IR running. The first one is the one that already been provisioned before. It's started. The second one is still being provisioned because it takes 10 to 20 minutes. The other one is also, the first one is done through PowerShell. The second one is done through a UI. That's it for the demo. And this is all the resources that you can learn more about what I presented. That's my email if you have any question. And there's also an online survey for you to enter to submit your scenario, the type of use case that you want us to support, for example. And then there's the SSIS Advisor Yammer group, where we actually discuss what a new feature to add. It's under NDA. And please evaluate this session. And that's it. Now for a question. Sorry if I run over time. There's a lot of material there.